What's up, calculus? Welcome to coronavirus lessons. I made this up because I saw two people have gotten onto this far of the 5.4 definite integral stuff, question number 7. So here we go. They asked you to first find the function right here. Like this is the function they're asking you to graph on the interval pi over 6 to pi over 3. The student got it wrong at first, although the pi over 6 to pi over 3 is doing well here. This is not what sine is doing for sine of 6x. All right, so let's remember, sine of 6 times pi over 6 is the same as sine over pi, which is 0. Sine of 6 times pi over 3 is sine of 2 pi, and that's also 0. Remember, pi over 6, if I can make this a little bit bigger, pi over 6 and pi over 3, pi over 4 is right in the middle, right? So this graph that they chose here is in the right interval. Question D is, or option D is definitely not. Question C is in the right interval, just the wrong values of sine for the endpoint, right? Question B is in the right interval, but again, sine is not -1 at the endpoint. Option A is really what we want to choose. That was the right answer. So you know what the graph looks like. Why this is important is because it's below the x-axis and it's going to be a negative area in the end. So any answer that we get to approximate the net area bounded by the graph, using a left to right or a midpoint sum with 5 subdivisions is going to be something that is a negative value in the end. And we are going to use our calculator. All right, so I'm going to use Desmos to show you. Okay, I guess let's go there right now to Desmos. Desmos is over here. So you could see a few things. You could see that, this is our graph and these are the 5 partitions, but you might be wondering, like, what are those? How am I supposed to split up pi over 6 to pi over 3 5 different times? No worries, people. Let's go over to this, all right? Let me hide some things. First, you have your pi over 6 to pi over 3. Here are your 5 even divisions. Those are your 5 even divisions right there. All right, what are those? Well, you got to figure out what the width of each rectangle is, right? There's the total width of the interval. The distance between pi over 3 and pi over 6 happens to be pi over 6 long. We're dividing it 5 times, right? So just some algebra here. Pi over 6 divided by 5 is pi over 30, right? So this distance right here is pi over 30. What the heck does that look like? Well, it makes more sense when you get common denominators. Pi over 6 is 5 pi over 30, and a pi over 30 distance away from 5 pi over 30 is 6 pi over 30, then 7 pi over 30, 8 pi over 30, 9 pi over 30, 10 pi over 30, which happens to be our ending interval at pi over 3. All right, so there's our 5 even subdivisions, right? So let's go back to Desmos here, and the first thing that they're asking us to find out is, moving too many things here. The first thing they're asking us to find out is, I think, a left or a right-hand sum. Let me actually go back to the problem so that we can see here. All right. They're asking us first to use a calculator to approximate the net area using a left Riemann sum with n equals 5. All right, so a left with n equals 5. Student got it wrong. We're gonna figure out what exactly it is. But here's how this works. Let's go back to Desmos again. Visuals matter. All right. A left-hand sum means that in this first rectangle, which could be outside of the curve or nothing inside of the curve, we need to choose either the left or the right. We're going to choose the left for the height. So this first rectangle is going to have a 0 height. All right. The second rectangle here, bounded by green and black here, is going to choose between green and black right here is going to be the left endpoint, right? So that's going to be under. The third rectangle between black and purple is going to be underneath. All right. And I choose the left. The fourth rectangle between the purple and the orange is going to be over. All right. And the last rectangle between orange and this blue endpoint is going to be using the left, and that's going to be over as well. So some are going to be under, some are going to be over. They're all going to be left. It's okay. So now, how do you actually go about and find it? Well, the formula is just, area of a rectangle, width times height, and we're just adding a bunch of those together. The cool thing about it is the width is the same. The width is always going to be this pi over 30. All right. The height is going to change depending upon where your input is for each height. Some will be longer, some will be 0. Some will be as long as they can get. This purple and black will be as long as they can get. All right, the orange will go down, and then the black or the blue would be the 0 height, right? All right, so we know the width is pi over 30, and again, I need to find the height using the function. So my height there is going to be f of pi over 6. I'm going to add to that f of, well, if you remember what our divisions were, the next one is 6 pi over 30, all right? I'm not even going to reduce that. I'm just going to call it 6 pi over 30. In fact, I can make this one 5 pi over 30, right? And I'm going to continue on, just keep adding these f of 7 pi over 30. Then I'm going to be adding now f of 8 pi over 30. Don't worry about reducing these while you're calculating it. We just need to make sure we have 5 different heights. There's 1, 2, 3, 4, and I need one more height, so that's going to happen at adding f of 9 pi over 30, right? So let me go back to my sketch here. I'm using the left one, so I'm using this one, this one, this one, this one, this one, but not this one. If I look at my calculation, 9 pi over 30 was my last one, and 5 pi over 30 was my first one. It's times the width each time, and that gives us an area of negative 0.3222, or 3223 if you round up. All right. Now, as we go to answer this, right, whoever I'm correcting here will probably get some free homework done. All right, you're welcome. Let me see. Did they actually answer that? Well, I don't know if they answered it wrong, but I think the calculator answered it for you. The funny thing is, using a calculator to approximate the net area using the right Riemann sum is going to be the same area. Take a look. Take a look at this. If I do a 0, then this green heighted, then the black heighted, then the purple heighted, then the orange heighted, the right hand, I'm going to use the green. It'll be under. For my first, or excuse me, I'll use the right hand green, which will be over, right? Then the black, which will be over, then the purple, which will be under, then the orange, which will be under, then the pi over 3, which will be 0. It's the same rectangles as the other one. So the left and the right, because of the symmetry of this, will definitely be the same. So negative 0.3222, all right? And so there it is. All right. I do believe, I don't know if this is actually letting me do it on another student's page here, but the next question asks you to find the midpoint. So I'll go through that right now. You'll see it on Desmos, but I won't be able to put it into the computer. All right, it's not a big deal, but we'll find it out. All right, so the midpoint is different. I'm gonna go back to our picture. Instead of using the black or green, we're gonna use a midpoint that's in the middle, and that rectangle will go out and inside the curve. Between green and black, we'll use a rectangle's height, which is in the middle of those. And again, that rectangle will be half in, half out. All right. You can see what the height of the next rectangle is going to be. It's going to be at pi over 4. That's right in the middle. And then whatever's in the middle here, and then whatever's in the middle here. So I'll get rectangle areas for all of these. All right. But this is where it gets a little tricky. All right. You've got to use, here's our normal, 5 pi over 30, 6 pi over 30, 7 pi over 30. All right. You'll see those same things, but now I need to cut these in half. So this 5 pi over 30 is the same as 10 pi over 60, 12 pi over 60. right? If I don't do that unreducing, right? If I hide that, if I try to find the middle of 5 pi over 30 and 6 pi over 30, then I'm talking about 5.5 pi over 30, which nobody likes. But when I unreduce these, 10 pi over 60 and 5 pi over 30 are the same, 12 pi over 60 and 6 pi over 30 are the same. I'll know exactly what's in the middle. It's 11 pi over 60. There they all are. I got 11 pi over 60, 13 pi over 60, right? There they all are. So I'm using these midpoint heights, starting at 11 pi over 60, going to 13 pi over 60, 15 pi over 60, 17 pi over 60, 19 pi over 60. All right. So we'll go back to Desmos and figure this out. So I got to go back and forth because I already forgot where I had to start. All right, so my first height is going to be at 11 pi over 60. All right, so 11 pi over 60. So I'm going to change my first height from 5 pi over 30 to 11 pi over 60. Let me get this over there. All right, to 11 pi over 60. Next one's going to be 13 pi over 60. Next one's going to be 15 pi over 60. Next one's going to be 17 pi over 60. And then the last one's going to be the 19 pi over 60. All right, and there's the midpoint formula sum. Going to be negative 0.339 for this particular problem if you wanted to finish it. All right, ladies and gentlemen, not too bad at all. I hope everyone's doing well. I hope everyone's doing fine. I really hope no one's caught this virus. I hope nobody's family members have caught this virus. Hopefully this video gets you through and you can start doing some of these problems in the definite integral section. All right. I hope to see you in the next Google Hangout. Didn't do too well in the first one, but hopefully we'll get together on the next one. All right. Miss you guys all. Have a good day. Bye-bye.